What's going on, everyone? So last time we talked about derivatives, right? We define a derivative as the rate of change or the slope, right? Rate of change or the slope of a function. And we said that if you wanted to find the derivative based on the definition, right? It would look like this. So you would take the derivative with respect to x, right? Of some function f of x. And that would look like this. The limit as h approaches 0. At the top, you have f of x plus h, right? So wherever you see x in your original function, you replace it with x plus h minus your original function all over h. And you would evaluate this to find your derivative, right? And you would find your answer. Today, I want to go over a faster way to calculate the derivative using the power rule. And in a sense, it's going to be a shortcut, okay? And so let's say I have a function, right? A general function that looks like this, right? Some base x, right? Raised to some exponent n, my exponent, okay? And so if I want to find the derivative with respect to x, right, of my function x raised to the n, I'm going to do this in 2 steps, all right? So the first step is to multiply my exponent by the coefficient, right? The coefficient is just the number behind the variable. So for example, for the number 2x, 2 is your coefficient, right? Similarly, if I gave you 5x squared, 5 is your coefficient. If I gave you 7x to the third, 7 is your coefficient, okay? And so, in this case, your function x to the n, right? This is the same thing as saying 1x to the n, but the 1 isn't there because it doesn't need to be. So 1 is your coefficient. And so what you're going to do is you're going to multiply your exponent by your coefficient. That's going to give you your new coefficient. Okay? And so let's do this. D over dx of x to the n is equal to n, right? N times 1 is your new coefficient. So that's just n. Your x stays there, right? The variable stays, or the base, sorry, stays. The second step you're going to do is you're going to subtract 1 from your exponent. Okay? So that means up here in your function x to the n, your exponent is n, so you're going to subtract 1 from your exponent. And this is going to be, right, the general formula for the shortcut. So this is the general, we'll call this the general shortcut. Okay? So to highlight this, let's work through a couple of problems, right? And these will be similar to the ones we did with the definition so that you can look back and check, okay? And so let's say I'm considering the function, right, of our trusty parabola, all right? So in this case, the base is x, your exponent, right, is 2. And so let's follow this 2-step process. So in this case, we know that x squared is the same thing as 1x squared, right? The 1 is kind of unspoken. It's like the silent letter, right? And so in this case, the first step is multiply the exponent times the coefficient. And this becomes our new coefficient. So 2 times 1 is going to be 2, right? We said the base is going to stay there. And then the second step is to subtract 1 from your exponent. So this is going to be, and actually let me write this out so you can see it. Right, so we said you're going to multiply your exponent, which is 2, by your existing coefficient, which is 1. Your base stays there, and you're going to subtract 1 from your exponent, right? So here you're going to get 2x, right, to the 1. X to the 1 is the same thing as x. So this is going to simplify to 2x, okay? And so this is the derivative with respect to x of your function x squared. Okay, let's do another one just to try to catch the pattern here. Okay, so the next one is going to be the function f of x is equal to 5x plus 7. Okay, you give it a try and pause the video and we'll go over it in a minute. Awesome. So when you were doing this, right, you're trying to find the derivative with respect to x of the function f of x, meaning you're trying to find the derivative of this first term, right, plus the second term, so this entire right side. Teaching point, when you see the derivative of an entire expression, just know that you need to remember you are going to distribute the derivative to each term inside of that expression, okay? So this is the same thing as the derivative with respect to x of the first term, which is 5x, right? Plus the derivative with respect to x of the second term, okay? And we'll go over this in a minute. In terms of properties of derivatives, 7, right, just like any other number, 1, 2, 3, and so on. The derivative of a constant, right, and constant is defined as any just a pure number, right, 1, 2, etc. The derivative of a constant is always going to be 0. So the derivative of 7, which is a constant, is 0. So this term falls out. And here, let's use the definition of the power rule that we determined up here. So 5x, right? So this is going to be 5. Think of x as x to the 1, right? And so if we're finding the derivative, and I'll do it over here, the derivative of x to the 5x to the 1, right? Our exponent multiplied by our existing coefficient is going to give you 1 times 5, right? And we said that's going to be our new coefficient. Our base stays there, and you're going to subtract 1 from your exponent, right? That's step 2. So 1 minus 1. When you solve this out, this is going to be 5x to the 0. And let me clean this up. Second teaching point. In this class, right, anything, and I'll represent that by an A pretty much, anything raised to the 0 power is going to be equal to 1, okay, for intents and purposes of this class. Anything raised to the 0 is going to be 1, and so x to the 0 is 1, and so this whole term here, right, that's equal to 1, so you're going to have 5 times 1, which is just going to give you 5, okay? And so 5 is the derivative with respect to x of 5x plus 7, okay? So if you're following so far, you're doing great, all right? Let me give you one more example for you to work on, and then we'll go over it together, okay? So the next one we have is the function, our trusty 3x plus 2. Okay, and I want you to find the derivative of this using the shortcut, okay? And we said that the shortcut is if we're taking the derivative with respect to x, right, of x to the n, that's going to be n x, exponent minus 1, right? And our steps, remember, that the first thing you do is you're going to multiply the exponent, right? Multiplied by the existing coefficient. This is going to give you your new coefficient, right? And the second step is you're going to subtract 1 from your exponent. All right, so go ahead and give that a try. Sweet. So when you were trying to find the derivative of this function using the power rule, right, you were essentially trying to do this. Find the derivative with respect to x, right, of your function f of x. And that was the same thing as finding the derivative with respect to x of this entire right side, right? So 3x plus 2. What we said in the last example was anytime you see that you're taking the derivative of some expression, you have to remember that you're going to distribute, right, the derivative to each term in this expression. And so this can be written as this, the derivative with respect to x of the first term, 3x, plus the derivative with respect to x of the second term, right? We also said that the derivative with respect to x of a constant, and we define a constant as just a number, right? This can be like 1, 2, 3, and so on. The derivative of a constant is always going to be equal to 0, okay? And so 2 is a constant, so this we can automatically kick to 0. Now we're going to look at this, okay? We're trying to take the derivative of 3x, which is the same thing as 3x raised to the 1, right? Same difference. So step 1 is to multiply the exponent by the coefficient. Exponent multiplied by the coefficient is going to give you, right, our new coefficient, exponent times coefficient. The base stays. Then you're going to subtract 1 from your exponent, okay? So 1 minus 1, and you're going to solve this out. So this is going to be 3x to the 0. And remember, we said for this course, anything, I'm going to represent that by a, anything raised to the 0 power is always going to be equal to 1, okay? So in this case, this term goes to 1, right? And so you have 3 times 1, which is just 3. And this turns out to be the derivative with respect to x of your function 3x plus 2. Okay? So if you are following up to this point, okay, good job. If you're having a little bit of trouble, totally fine, okay? So just go back through the thought process for these two example problems, okay? So before we kind of continue with more examples, right? I want to go over properties of derivatives, and this is really important actually, okay? So properties of derivatives. And these are basically tools that you have when you encounter different types of problems on homework, quizzes, tests, okay? So take these down and learn them, all right? The first one is kind of what we've seen already in this video, sorry. So if you're trying to find the derivative with respect to x, right, of some expression, like we said before, some expression f of x plus g of x, right? And we're going to assume, right, when we're talking about properties of derivatives, that the functions are differentiable, meaning they have a derivative, right? For now, don't worry about this too much, okay? But if we're taking the derivative with respect to x, you got it, of this expression, we said you have to remember that you're just going to distribute the derivative to each term inside. So in general, this is going to simplify to the derivative with respect to x of f of x, right, the first term, plus, that comes over, the derivative with respect to x of your second term, g of x. Okay, this is the first property. The same thing can be done if you just simply turn that positive into a negative. All right, so the derivative with respect to x of some expression f of x minus g of x, right? Same thing, you're going to distribute the derivative in to each term. So now you're going to have the derivative with respect to x of f of x minus, right, minus the derivative with respect to x of g of x. Okay, these two are basically the same. All you do is flip and flop the plus and minus. Right? Here's where it gets interesting. All right. If you're taking the derivative with respect to x now of a function f of x multiplied by a second function g of x, okay? This is where you're going to use something called the product rule, okay? And I'd write that down. You're going to use the product rule, and it's going to follow, right, in layman's terms, right, in street terms, I guess, or lecture hallway terms, f prime g plus g prime f. I'm going to go over what this means right now. F prime represents the derivative with respect to x, right, of your function f of x, right, of this first term. G is just your original g of x function. You're going to perform this product, right? You're going to multiply these together. You're going to add it to this term over here. In this case, g prime is the derivative with respect to x of g of x, right? This second function in here. And f is going to be your original. So I'm going to call this original. F over here and over here, this is going to be your original g. Okay? And so what this is going to look like is this. So f prime is going to be d over dx, derivative with respect to x of f of x, right? Multiplied by just regular g of x. We're going to add this, right, to g prime, which is the derivative with respect to x of g of x, multiplied by your original f of x. Okay? And so this is what this one is going to look like. So I'll write down here, respect to x of f of x multiplied by g of x. This right here is your derivative using the product rule. All right? And I didn't box these because there wasn't too much work. Number 4, if I'm asking you for the derivative with respect to x, right, of some function f of x divided by some function g of x, all right, this also gets interesting. You're going to use something called the quotient rule, all right? And remember this, I'll write it down, the quotient rule. And that formula, right, the hallway term for it, try to make something cool, is going to be f prime g minus g prime f all over g squared. Go ahead and take a sip of Gatorade before we continue. That was a lot. So Again, f prime, just like in the product rule, f prime represents the derivative with respect to x, right, of your f of x function, right? G, in this case, is your original g of x. G prime represents the derivative with respect to x of g of x, right? This bottom term. And then f represents the original f function, okay? And so you're going to do the derivative of the top term times the original bottom minus the derivative of the bottom times the original top, right? All that divided by the bottom squared, okay? And so this is the quotient rule. So this right here, all right? In addition to that, let's just highlight two more of the concepts we learned, right? We know that a constant, or we know now that a constant, just think of a constant as a lone number, right? So like 5, 6, 7, etc., right? We already said, and we'll recapitulate here, the derivative of any constant of just a pure number, right? Constant of 7, constant of, or derivative of 7, derivative of 13, it's always going to be 0, all right? And we also learned, the last one, that anything, I'm going to represent that as a, right? Anything raised to the 0 power, for all intents and purposes for now, are equal to 1, all right? So I hope this helped clear some stuff up. If you have questions or concerns, please comment below and I'll get back to you as soon as possible.